Hi, this is the video lecture for section 7.3 of statistics. And in this lecture, we're going to talk about QQ plots. So let's first try to understand why we care about QQ plots. In 7.2, you were able to use the normal calculator in StatCrunch in order to answer questions about all kinds of problems, you know, like how many M&Ms there were and what bolts would be discarded and things about gestation periods. And it didn't really matter what the topic was. The nice thing was that you could go into the normal calculator and you could answer questions about the probability of this occurring or how many of these should be in, you know, in a bag of M&Ms and that kind of thing. Okay, so the reason we were allowed to use the normal calculator is because in all of those questions, the data basically was normally distributed. So in other words, if you were gonna plot the data that was collected on a curve, it would give you the normal looking curve. If you were to create a histogram, it would have a normal shape to it. So that was what gave you permission then to use the normal calculator because the data was distributed in a normal fashion, okay? So what we know about data though is that when we have a lot of data, we can see the shape better. But when we only have a few, like if your sample size is only like 8 and you plot the 8 points, you know, or let's say you did like a histogram or something, it could like maybe not necessarily look normal, or maybe it kind of looks skewed right, maybe it's not skewed right. The bottom line is that if we have a small number of samples, right, like if our N is, let's say 8, or if our N is 5 or something like that, then it's really hard to plot that and determine the shape. So we need a different test in order to prove that the data came from a normal distribution. And again, why do we want that? Because we want to be able to use our normal calculator because it's easy and it helps us answer all kinds of questions about the data that we collected. So what we would do then, if our N was small, which it will be in everything in 7.3, is we can use this thing called the QQ plot in order to determine whether the data was normally distributed. And so the way that the QQ plot works is that you would take all of your data, let's say you had 8 samples, or you know, your sample size was 8. You could take each of those observations and you make an assumption that they're normal, and if they were normal, then you could calculate the z-score for each one. And we've done z-scores throughout the semester. We've taken observations and converted it to a z-score. And all the z-score does is it just tells you where on that normal curve it is in relation to the mean. So like if the z-score of the mean is 0, then here's a 1, a 2, a 3, a -1, -2, -3. So if you took all of your original observations and you converted each of those into a z-score, then you would have all of your observations listed as the actual observation and then also listed as the z-score. So now you have 2 different sets of data. And what you could do with those is you could compare them like using linear correlation like we did in chapter 4. Remember when we had like the height and weight of the bears and we wanted to know if the height and weight had a linear correlation, right? And we could plug that into our StatCrunch and it would tell us whether or not those were correlated. So here what we're doing is we're taking the observed data and we are seeing if it's correlated. So is that correlated? That's the big question, with the z-scores that we calculated from each observed data point. So if those two are correlated linearly, then what it tells us is that our assumption that they were normally distributed is true. Now, I know that's kind of a lot to think about, but I wanted you to have some context for why we're doing QQ plots. It's simply a way of deciding whether or not those observations came from a population that was normally distributed. Why do we want it to be normally distributed? So that we can then use our normal calculator to answer questions, okay? When would we use the QQ plot test? When our sample size is small and we can't really tell by plotting them and seeing what the shape would be. So if you were doing this by hand, this would be kind of lengthy because you would have to take each of the observations, use a formula mathematically to convert it to a z-score, and then plug in all your data, your observations, and plug in all your z-scores and find out if those are correlated. However, the nice thing is that we get to use StatCrunch for this. So now that we've kind of done an understanding, you know, and you don't have to be like, you know, the person who knows the most about this in the whole wide world, but just so you kind of get an idea of what's happening, let's talk about how we calculate these. So you do not need to do anything by hand in this section. You can do it all in StatCrunch. Then what you'll do is you'll choose graph and then QQ plot. And then kind of follow along. It'll ask you for the two different sets of data. You have your observed data and then you have your z-score data, okay? Again, this is similar to choosing, you know, the height as one set of data and the weight as another set of data when we were doing that bear question. All right, so what happens when you do graph QQ plot and you give them your observed and give them your z-score data is that it will spit out a correlation coefficient, which this should sound familiar. It's R. R is the letter they use to represent the correlation coefficient. So let's say your R was something like 0.910 or whatever. It's going to give you that by doing the QQ plot. And what you want to do then is you want to compare this with the critical value. And if you remember how to find the critical value, you would click on the critical value table, and then the table is going to give you all the values of n. So like if you had a sample size of 1, 2, 3, 4, all the way down to, let's say in this case it was 8, and then you look over and it's going to give you the critical value. And I don't know what the critical value is for 8, but let's just say it's 0.858 or something like that. It's pretty close. So what you do is you use your StatCrunch to figure out your correlation coefficient. It'll give that to you. And then you go onto the table and figure out what your critical value is based off of what your sample size is. And then you're going to compare these two numbers, okay? And this part should feel similar to what we did with the linear correlation. So how do we interpret our answer? This part is pretty much the same. The interpretation is if the correlation coefficient R is bigger than the critical value, then you can assume that the data came from a normal distribution. And why do we care about that? Because if something was normally distributed, then we would be able to answer all kinds of questions about it using our normal calculator, which you're pretty much not going to do in this section. You're just going to spend your time deciding whether or not it did come from a normal distribution. So remember, R is your correlation coefficient. You get that from StatCrunch. CV is your critical value. You get that from looking at the table. And that's it for this section. It should go pretty quickly and should be pretty easy compared to some other sections. I'll talk to you later.